The thermoacoustic Stirling engine is getting better and better thanks to the help of many developers. It is now possible to print the entire power extraction unit with a 3D printer. The goal of an easy-to-build, open-source engine for cheap electricity generation for everyone is getting closer and closer. The latest test runs produced an interesting surprise, offering hope of a huge improvement in performance in the near future. In the last video, I gave an insight into the practical development process and showed some test runs with a new membrane. Now, I would like to present some background information and additional results. The power extraction unit with a piston was complex, heavy, expansive and inflexible. The new membrane-based design is easy to print, very lightweight and can be tuned to the thermoacoustic frequency. After a few failed attempts with thin rubber balloons, cracked also, the engine ran very quickly and smoothly straight away when I used thicker rubber. Unfortunately, my Arduino test bench has a loose connection that I couldn't find right away. That's why I use a laser measuring device and an oscilloscope to measure the frequency. To do this, I quickly wound a very simple coil through which a magnet, attached to the membrane, can induce a voltage. As expected, the frequency is higher for smaller moving masses. At the lowest weights, the membrane oscillated at over 2,600 vibrations per minute, faster than ever before. I really need to connect the pressure sensor to the oscilloscope now and compare it with the voltage waveform. These are all excellent results, but it even gets better. During the test runs with the lightest masses, with the burner turned off and only a warm heater, the engine started on its own. And now it starts by itself. Even with heavier weights, the oscillation started on its own once the heater was hot. This greatly simplifies the process of pressurization, which is essential for improving performance. With the housing then closed, there is no need to develop a complex starting device. First, the entire engine must be made completely airtight. To do that, I have to rebuild the entire feedback loop. This time, it will be entirely 3D printed using clamping flange connections, which are highly practical and completely leak-proof. They can also be printed very easily. A compact linear generator for power measurement must be designed and integrated into the closed back of the membrane. I'm really curious to see if the boost pressure will actually deliver the expected performance increase. The holder and the membrane itself still have a lot of potential for improvement. Experiments with stiffness in the center have not worked so far because the membrane is stretched too tightly. The membrane is too stiff. I would also like to experiment with different types of membranes and cast or form them myself. Do you have any ideas about what an effective membrane might be like? Please post it in the comments, on Discord or on the forum on ownenergy.org. As always, I would like to hear your feedback, suggestions and ideas. If you would like to support the project, help us with the development and/or become a member on Patreon or YouTube. Thank you very much for your interest. Can you hear the sound?